Newton's formula for velocity of sound in gases, its error and its correction. Very, very important topic. Okay. Now, Newton have given the formula for the velocity of sound, and he said that this formula or this process to find out the velocity of sound in gases is purely isothermal. Isothermal means pressure, the temperature is constant. So in that case, he uses the coefficient of thermal isothermal elasticity, that is Bi, and gives the formula that speed is equal to root of Bi by rho. Okay, now let us calculate Bi first. Calculation of Bi. Okay, now here Bi is the basically isothermal elasticity. Okay, now let us consider a certain mass of a gas and let P be the initial pressure of the gas. In that case, initial pressure of the gas, P is the initial pressure. So, and we can say that V is the volume, and for isothermal process, PV is equal to constant. Since PV is equals to constant, so differentiating both sides, we will be having PdV plus VdP is equal to 0, or we can write PdV is equal to minus VdP. So in this case, we will change it to P, which is equal to minus V dP by dV. Okay, so P is equal to, this is dP divided by dV by V with negative sign. Now what is this? This dP is the change in pressure, and upon what? Upon change in volume upon volume, which is basically Bi. Okay, so we can see that V, velocity or speed, can be written as root of P by rho instead of Bi. Now what is the error in this formula? Basically, when we put the values, we know that pressure is equal to rho Hg. Okay, H is equal to 0.76 mm of Hg column, and the atmospheric pressure, we can say that density is given by 13.6 into 10 raised to power 3 kg per meter cube. Okay, and acceleration due to gravity is 9.8 meter per second square, and density of air is 1.293. Okay, so on putting these values, we write here air also 1.293 kg per meter cube. So putting all these values in this expression, we get V is equal to that comes out to be 280 meter per second. Okay, but the actual velocity of sound is basically this is 332. So the difference is 332 minus 280, which comes out to be 15% basically lesser. Okay, so this shows that there is not exact value if we consider that the process to find out the velocity in gases is an isothermal process. So Laplace gave its correction, and he succeeded in explaining the exact cause for that discrepancy between the theoretical value and the experimental value. He pointed out that Newton's assumption is that isothermal is wrong. Basically, the process is actually the adiabatic. Okay, and he proved this. Now, for that, the velocity is given by beta A upon rho, where BA is the adiabatic process. And we know the equation of adiabatic, which is given by PV raised to power gamma. Okay, so in this case, we can write that PV raised to power gamma is equal to constant. Now again differentiating both sides, P, this is gamma V raised to power gamma minus 1 into dV plus V raised to power gamma into dP is equal to 0. So this is again P gamma V raised to power gamma minus 1 dV is taken this side. So minus V raised to power gamma dP is taken to that side. So now simplifying it, this is gamma P, which is equal to minus V raised to power gamma dP divided by V raised to power gamma minus 1 into dV. So this gamma to gamma cancel out, V will go up. So this is minus V dP by dV. This is dP by dV by V. This is minus gamma P, or we can say that P is equal to this is equal to beta A. So in this case, we will put V is equal to, we know that BA by this is rho by Laplace correction. So we will put here gamma P by rho. Now if we put the values corresponding to this, here gamma is equal to 1.41. So in that case the speed comes out to be 332.5 meter per second, which is much closest to the practical value. Hence this Laplace correctly defines that this process is totally adiabatic.